Hello everyone, welcome to my presentation on IPFS. Let's get started. So what is IPFS? So the Interplanetary File System is an decentralized storage and delivery network that builds on fundamental principles of peer-to-peer networking and content-based addressing. So just to give a quick introduction about IPFS, IPFS uses something known as content addressing to uniquely identify each file in a global namespace of connecting and thereby connecting IPFS hosts and nodes. So this peer-to-peer transfer of data is actually not very new, and you might also have used some of these technologies before. For example, you might have used BitTorrent services, which functions on something similar to this similar network architecture. So this IPFS technology was proposed by Yuan Bennett in the IPFS white paper in 2014. So let's now talk about the different network topologies. As you can see, there are three different types of topologies, namely centralized, decentralized, and distributed. Now we'll talk about what the pros and cons about these topologies. So to talk about the centralized type of topology, this consists of a single server in the center of the network known as a hub, and this hub essentially connects to all the other different nodes in the network, and these nodes get their data from the central hub. So this type of architecture is very difficult to scale, and it also has a single point of failure. If your hub fails, then your entire network fails. So another better type of architecture for a network topology would be the decentralized approach. So this is very similar to how the internet functions right now. So this consists of multiple servers which are installed across different locations across the world, and because of this, the demands and failures are better handled when a particular hub fails. But because we need to maintain multiple hubs for fa- uh, for handling the demand, this is a very expensive approach. As your network scales and as the amount of data required to send also scales. An alternative to both of these network topologies is the distributed network. So why are we preferring distributed? So this is because this network can act as both the server and the client. So it can be a hub for transmitting data and a node for collecting the data. This type of topology offers advantages such as resilience, speed, scale. It is very scalable, it is efficient, and also it works on the trustless basis, which is what we've been learning a lot about in this blockchain course. So now let's take a look at other reasons on why using this distributed network, which the IPFS uses, is better than the existing network topology. So we can see that HTTP is inefficient and it's very expensive. So HTTP downloads a file from a single computer at a time, and instead of getting multiple pieces from multiple computers parallelly, so this makes it not possible to distribute high volumes of data, and IPFS is clearly a better option here. So peer-to-peer IPFS saves a huge amount of bandwidth, up to 60% when compared to the traditional methods. Using IPFS also guarantees that the history of your network is preserved. So currently the average lifespan of a web page is about only 100 days, and then it disappears forever. So this is very bad because right now our humanity, our history is basically stored online, and this means that a lot of our human history is destroyed every day. IPFS provides a great historic versioning for solution for this. It uses something similar to Git, and it makes it simple to set up resilient networks and also to create mirrors of existing data. Finally, it is also a way to liberate the web. So the internet has always turbocharged innovation by being one of the greatest equalizers in history. But recent developments has made it such that the powers of the internet has been consolidated in few hands, and this threatens progress in the future. So IPFS stays true to the original vision of an open and flat web by delivering the technology to make that vision a reality. So now let's take a look at how IPFS actually works. So this is a simplified flowchart of how you can expect IPFS to work, and yeah, we'll take a look at it more in detail in the coming slides. So yeah, so imagine we were, to add a file to IPFS. So when we do this, the particular file would be split into smaller chunks, and these chunks will be cryptographically hashed, and they will also be given a unique fingerprint known as a content identifier or CID. So this CID acts as a permanent record of your file as it exists as it exists at that point of time. So when other nodes want to look up your file, they'll ask their peer nodes who are storing the content, which will be referenced by the CID or the file's hash. And when they view or download our file, they will also cache a copy of the file, and that node will later become will store the file, and if anyone else wants to look up your file, they can get from that node. And this is stored until your cache is cleared. So, but if you wanted to store it permanently, a node can pin content in order to keep it forever, or it can discount content it hasn't used in a while to save space. So this means that a node in a network only stores content that it is interested in, and it can also store some indexing information if it wants to. So suppose you want to change your file. You can do this by simply adding a new version of your file to your IPFS. This is possible, but when you do this, the cryptographic hash changes, and because the hash is different, it also gets a new CID. So this means that files stored on IPFS are resistant to tampering and censorship. Any changes to a file doesn't overwrite the original, and the common chunks across the files can be used and reused in order to minimize the storage costs. However, this doesn't mean that you need to manually remember a long string of CIDs for every website that you want to search. IPFS can instead find the latest version of your file using something known as an IPNS decentralized naming system. And it can also use DNS link to map the CIDs to human readable DNS names to surf the web basically. This is an example of possible IPFS stack where your applications are written on LibreWeb, and the naming conventions are handled by SFS. The IPFS's data structure, which operates on the Merkle directed acyclic graph, is similar to the Git versioning system. And and also the routing is done by DHT distributed hash table methods. And essentially you can create your web apps using a stack like this, which runs on the IPFS. So now let's take a look at how data is stored on IPFS. So data is stored in chunks of about 256 KB called IPFS objects, and files larger than that are split into many objects, many different objects of that particular size. So one IPFS object per file contains links to all the other objects, so that from one particular link file we can access the entire all the other objects as well. Data storage also makes use of something known as checksums. So basically, when a file is added to the network, it is given a unique 24-character hash ID, which is the CID, and and you can check the integrity of the file by basically recalculating the hash whenever you retrieve the file. And if the checksum fails, then you know that your file has been modified. And when files are legitimately updated, like we saw in the previous slides, IPFS has a versioning system, and the new version of the file will be stored along with the previous version instead of overwriting it. And this means that IPFS operates like a distributed file system, and this concept of versioning provides a degree of immutability to that system. Now let's take a look at how data will be retrieved on IPFS. So let's assume that you store a file on the node, and someone requests it and they download it to their node. The next person who asks for that file can get it from either the original node or from the new person's node. And this functions in kind of like how you use BitTorrent, and you can get parts of the data from both of these nodes parallelly as well. So this speeds up. So the more people who download the node, there are more nodes which are basically seeding the network, and this helps up speeding up the entire download process. You can also pay for storage on the cloud, so that you can expose your data to the IPFS permanently, and to have more number of nodes which hosts your data. And if something on your particular website happens to go viral, then the data will be cached on many different nodes, and those cached pages will be used to help service further page request. And you can your basically the demand will be satisfied because in a more uniform manner. And yeah, all of this requires that a sufficient number of nodes are actually on and available in the IPFS network. And yeah, this brings us to the number of the challenges with IPFS actually. So there is a lack of strong economic incentives for these nodes to operate. So since the start, IPFS has been built as a sort of a community product that benefits from everyone's contributions. But because of this, there was no incentive put place to grow this network. But the lack of economic incentive do not weaken the technology or what IPFS aims to do. They simply just make it an impractical solution for the long term use, especially for storing private and enterprise data. Which brings us to the second challenge, which is it is very unreliable with private data. So the old times of using BitTorrent or IPFS, they have been used to share voluntarily collaborative data such as academic research or movies, books, or music files. But there isn't really a proper way to ensure that how private data can be maintained, and also a proper way to ensure that the data is deleted across the entire network. So once you put a data onto the IPFS network, it is almost impossible to delete it at all. So let's move on to something known as Filecoin, which is brought from IPFS. So a Filecoin is basically an open source public cryptocurrency, and it is a digital payment system intended to be a blockchain based digital storage and data retrieval method. So Filecoin is an innovation that sprang from the applications or the probable applications of IPFS, and what it does differently is that it introduces an economic model and incentive that was lacking in the original IPFS white paper. So in simpler terms, Filecoin can be considered as an electronic currency like Bitcoin, and users can simply provide a portion of their unused storage in their laptops or their personal computers in exchange for this currency. So as you basically stake, instead of staking your coins, you're staking a part of your hard drive to the networks, and in return you will get Filecoins. So yeah, this brings us to the citations for and other resources where you can read up on IPFS and Filecoin. So yeah, thank you.